Alright, good morning everyone. Before I start my presentation, let me introduce myself. My name is Michel Tahya and my student ID is 12312101003 and I'm from 12H and today I'm going to presentate my research, statistic research on teenager sleep hours. Research question. How many hours do Indonesian teenagers sleep at night during weekends after using their smartphone up to 30 minutes before bed? So in this research question, I gather up some things that I want to know, and it leads to the purpose of the research. And this research question is going to lead the whole research, and of course the whole statistics later. Determining population sample. So the population is Indonesian teenagers who use the smartphone up to 30 minutes before bed on weekends. But the sample that I've got is through my survey. Is some Indonesian teenager who filled the survey, and 23 of them use their smartphone up to 30 minutes before bed on weekend. So the people who filled my survey, there were about 30 people, I think, if I'm not wrong. Yeah, less than 30 people. But I want to focus on the ones who use their smartphone up to 30 minutes before bed on weekends so that I can shrink the population even more. Because Indonesian teenagers are so many in this country. And then, yeah, I just want to narrow the possibilities and the population of value, the size of the population, so something like that. And here we got the data of the sample. These are teenagers who use smartphone up to 30 minutes before bed on weekends and their hours of sleep. So as you can see, there are 23 teenagers, um, and you can see their name. These are their first name, and this is all I got from the survey. And on the right side, you can see the sleep hours ranged from 4 hours to 11 hours. Now, determining sampling technique. So for this research, I'm going to use non-probability sampling, which is purposive sampling. So the reason why I'm using purposive sampling is because I want to be the one to find the sample that can fit as the representation for the whole population. So as you can see here on, especially at point 3, reach out to teenagers with different ages. So I reach out to them purposely, right? From the social media, and I ask them to fill out the survey, and I also uh, spread it through the Discord server, so that the Discord server that full of teenagers, so they can fill it, and I list their ages as well. So their ages are like from 15 years old to somewhere 20s. And yeah, so I got teenagers who is in still high school, junior and senior, and I have some teenagers from the college students, and I got teenagers who already have jobs. So yeah, I have each section so that they can represent the whole population. So that's why I choose purposive sampling as my technique. And the next is single data descriptive analysis. So as you can see, the left side is the sleep hour ranged from 4 to 11, and the frequency is in the right. So you can see the frequency of each sleep hour from the teenagers of the sample. So here's the main. So now we're going to talk about the descriptive analysis data, and these are the mean from the single data descriptive analysis. And as you can see, these are the formula. So I multiply them with their own frequencies, the sleep hours and the frequencies, and then I add them all up. And then I divided them by the total of the teenagers of the sample, which is 23, and I got the result of the median is 7.48. So the next is median mode. So median is like the when it's sorry. So median is like when it's orange, sorted, and the numbers is sorted. For example, like from 4 to 10, and it is sorted, and we're going to take the middle number, and the middle number here is 8, which is in the 12th number. So, and the mode is the number that occurs the most, and it means that it has the most frequency. So in this case, I have 4 sleep hours, 4 numbers that has the most frequencies. They have 4 frequencies. So the number 5, 7, 8, and 9. So the mode is 5, 7, 8, and 9. The next is variance, and these are the formulas of the variance. So we need to subtract the number to the mean that we got earlier, and then we par it by 2, and then we divide it, and we sub them all up, and then we divided them by 23, and we got the result of 0.432 after variance. And then we got the standard deviation. So this formula is actually pretty close to the variance, but here in standard deviation we root them by 2. Yeah, we square root the previous formula. So as you can see, we got the 4.32 earlier, and the square root of 0.432 is 2.07. And next we got average deviation, which is also kind of look the same with the formula before, but before they power it with 2, like number up there, but in the average deviation they do not do that, and they just add them all up and then divided it by 23, and we got the result is 1.76. I'm sorry. And then next we got quartile. So quartile is like the data sorted, and they just like divided into 4 pieces, 4 parts equally. So yeah, 4 parts. So like the segment between those parts is called key 1 and key 2 and key 3. So so it has up to key 3 because it's divided by 4, of course. So here are the examples of the calculation of the quartile. So I want to find out the key 1. So I got it's in the sixth value. So here it means that it's the 6th value. So the 6th value is 5 when it is sorted, of course. And then the key 3, it's in the 18th value. So the 18th value is 9. So the key 3 is 9. So that's it. And this R is like the same as quartile, but instead of dividing them into 4, this formula divided them into 10th. So like, yeah, they divided into 10th. So it almost has the same formula, but with this one it was divided by 10. Why before it was divided by 4. Now you can see here, and for example, I want to find the D1, right? So I put on the formula, and then I got 24 divided by 10, and we got the 2.410, 24, 2.4 value of observation. Now, of course, that this needs to be rounded number, right? We cannot find the word like 2.4 value of observation. So we need another formula, which is this, and so this formula will find out what this means, right? What this is trying to tell us. What is the exact value? So here we can see the formula, which is second plus 0.4 divided by the third and the second number, because it's second, and we just need to subtract it with the number next to it. Yeah. So the third number is 5 and the second number is 4. So 5 minus 4 is 1, and then 4 plus 0.5. 4 plus 0.4. I'm sorry. 4 plus 0.4 equals to 4.4. And percentile is the same as decile and quartile. So we divided the numbers into several parts. In this percentile, it's divided the parts by 100. So yeah, for example, you can just look into the formula. For example, I just wanted to find the p5, so we just put in the 5 there to fit into the formula, and we got 120 per 100 divided by 100, and we got 1.2 value of observation. Sorry. So yeah, and this is how we find. So the first number plus, because it's first, we need to subtract it with the next number, which is the second, and then we divided it into 0.2. So the first number is 4. As we can remember, the lowest value of the data was 4. So 4 plus 0.2 times by 0. So it's just 0. 4 plus 0 is 4. The next we have the quartile deviation. So quartile deviation, as you can see, the standard deviation of the quartile. So we just need to subtract the number. So I'm using QD here. So yeah, I'm using QD here. So Q3 minus Q1 divided by 2. So earlier I already got the number of Q3 and Q1, which is 9 and 5. So I just need to subtract them. 9 minus 5 is 4. 4 divided by 2 is 2. So the quartile deviation value is 2. Now we move on to the grouped data descriptive analysis. So from here, as you can see, we have the sleep hour, the frequency, and the cumulative frequency. I need this cumulative frequency later because I need to make the, what is it called, the OGIF graph layer, but it was just for layer. So as you can see here, I grouped the sleep hour into 3 classes, the 4 to 6, 7 to 9, and 10 to 12. And the class interval is 2. So this group data is like they grouped the data into classes. So the frequency is also added to each sleep hour in the same class, of course. Now, different from the it's kind of different from the single data descriptive analysis. The main formula is kind of different. The same thing is that we need to divide it by 23 to the total amount of respondent, to the total amount of data. But here we need to, so before we just need to multiplicate the frequency with the sleep hour, right? But here we need, because it was, as you can see here, it was orange, so we need to multiplicate the frequency with the number in the middle of the sleep hour. By I mean, like, we just plus this add this both of these number, which is going to be 10, and just divide it by 2. It's going to be 5, right? 5 times 7 equals to 35, as you can see here, and it all follows according to the data. And as you can see, we got the result here, 7.608 as the mean. And here we got median. Now the median and mode layer has like a significantly different formula, and here is the formula for the group data. So median equals to, so this layer means that, as you can see here, median is like the middle number of the data, right? Sorted. So as I told you earlier, the 23, the middle of 23 is kind of like 12th or 13th number. No, it's 12th number. It's the 12th number. So the 12th number is going to be here, according to the cumulative frequency, of course. So it's 7 to 9 hours. Now we can see here that 6.5 is the is bottom, like the tip bottom of the class of the median. So then we input the n is like the total of the data, and this is the frequency cumulative before the class of the median. So as you can see here, it was 19, and the before is 7, so you input 7 here, and this is the frequency of the median class, which is 12, and we multiplicate it with 2, which is the class interval, and then we finish the equation, and then we got the final result, which is 7.42. The next is mode. As I said earlier, the formula is really different from the single data, and here we got mode equals to, so this is like the lowest data of a class, which is the mode, which is the class that have the class that has more frequency than the others. As you can see, it's this class again, and the lowest sleep hour is 7. So that's what we need here, 7. And here, as you can see, it has like frequency, yeah, cumulative frequency, and this is like cumulative frequency before the mode class. And here we can see the frequency cumulative data after the mode class. And we just need to input a number, which is 12. the oh, I'm sorry, this is not the cumulative frequency of the class, but this is the frequency of each class. I'm really sorry. So the frequency is 12, before that it's 7, and we times it by 2, before it's 7, and after it was 4. And as you can see here, after the median class it was 4, and the final result of the mode I got is 7.77. Now we got the variance. The variance is here. You can see the formula. It's kind of similar to the single data group, single data descriptive analysis, and yeah, here you can see numbers, and as the same like men were, yeah, the same like the men, that this needs to be like the number in the middle of the class, not like the whole class, but like the number in the middle of class. For the first class we have 4 to 6 sleep hours, so we need to input 5, and yeah, we need to input 5 into here, and this is the frequency of each class, and we add them all, and we divided it by 23, and we got the final result of 2.739 as a variance, and then the standard deviation. Now notice that this symbol is the same, but for the variance it is powered by 2, and here is just the symbol, because that is what standard deviation means. So as you can see here, there's like a square root, and of course it makes sense due to some algebra, and we, yeah, and then because we already got the number here, 63, we just square root the 2.739, which will get us the number 1.651 as the standard deviation. Next is average deviation. So I used it 80 equals to, it's also similar to the single data descriptive analysis. I'm sorry, not analysis. And then here's the frequency, and here we use the middle data of the class to subtract it with the mean, and we just add them all up and divided it with 23, which is the total of the data, and we got the number of 1.588 as the average of deviation. Next is quartile. Because this is group data, of course we need to change the, not wholly, but not fully, of course, but it's kind of different from the single data descriptive analysis. And this is let's just, so here is when we need to find where is the quartile, like the Q1, Q2, and Q3 is exactly, like we want to find the value of them. So this only needs this formula just going to tell us where is it, and this formula, well, yeah, this formula is going like, I'm sorry, and this formula is like telling us the exact value of, after we find out the position of the value. So here I already got the Q1 and the Q3, which is 5.142 for the Q1 and the 8.208 for the third quartile. And here we got the quartile deviation. I call it as a KD, so it's exactly the same formula as the single data group analysis, because quartile deviation doesn't have anything to do with the shape of the data, because as we get the quartile values, and we just can operate the quartile deviation because it has the same formula. And yeah, as the data goes on, and as the data been um, gathered and things like that, then gained, it doesn't really affect the quartile deviation. I'm like for the form of it. So like 3.66 divided by 2 is going to be 1.533. And next we have relative deviation. We didn't have this in the single data descriptive analysis, so I only call it as RD. And these were the standard deviation, as you can see. And we're just going to back the standard deviation is this, and we got the number, the value is 1.688. We're just going back to the relative deviation, which is 1.655 multiplicated with 100, and then subtracted with the mean of the data, which is 7.608. And here we got the final result to 21.753 as the relative deviation. Next, we're going to talk about the data visualization, which is the pie chart of sleep hour. And this is the pie chart. As you can see, this color represents these 4 hours. Yeah, this one, and the 5 hours this one, 6 hours, 7 hours, 8 hours, 9 hours, 10 hours, and 11 hours. So here's the pie chart, and next is the bar chart. As you can see here, it represents the data more visible. As you can see, we're talking about the frequency here. Now we can see it clearly that, for example, 4 hours there are 2 teenagers, 5 hours there are 4 teenagers, 6 hours there are only 1, and that's how you know it. And next is the histogram and the frequency of polygons. So before this from the single data descriptive analysis, and this one is from the grouped data. So as you can see here, this is the first class, the second class, and the third class. And this is like the tick button, I think. Yeah. And from the histogram and frequency polygon. So next is the Ogive graph. So this is why I need the accumulative frequency. So the frequency is accumulated from each class to another. For example, the first one was 7. I don't know, we cannot see here, but it's supposed to be 7. And the next class has frequency of 12. So we just add 7 to 12, which is going to be 19. And then we have 19, we add it to 4, because the last class has 4 frequency. And 19 at 4 equals to 23 here. So 23 is like the total data that my sample has, so that makes sense. And the next, last but not least, is the probability case. So I have 2 cases here that we're going to talk about. And yeah, this is according to the data that I've gathered from the sample. And I trying to make the probability case from this data. So according to the data, which is the sleep hour of teenagers data, what is the probability of they have recommended hours of sleep? Around 7 to 9 hours. So yeah, so my focus here is like the frequency of sleep hour from 7 to 9 hours, 7 included and 9 included. Of course, 8 also on weekends, even though they use their smartphone up to 30 minutes before that. So the answer is this: teenagers who sleep to 7 to 9 hours, according to the data, there are 12 people. And let's just see from the data, 7 to 9. So let's calculate. There are 4 4 times 3 is equals to 12, right? So there are 12 people among the 23 people that sleep well. I mean, like, they sleep as they're supposed to be, like the recommended hours of sleep, which is 7 to 9 hours for teenager. And then they have the, and then we just input it into the probability formula, which is P probability equals to X is like the oh, I'm sorry, the X is like the number of occurrence and the data, and the T is like the total of the data, something like that. So we have 12 divided by 23, so it's equals to 0.521. So this is like we can take this information. So like, what is like the probability of teenagers who sleep at weekends and they use their smartphone up to 30 minutes before bed and they sleep well and they sleep recommended hours, from the scientists or whatever. And we can say, oh, it's like 0.5 to 1. Yeah, sounds like that. So it's like saying, oh yeah, it's 52.1% uh chance or something like that. So the second one, if teenagers who sleep above the average time claim that they feel passionate to start their activities after they wake up the next morning, but the others don't, then what is the probability of the ones we don't? So what I'm talking about here is like, so we're talking about the who sleep above the average time. So average time, what I'm talking about is the mean. So it doesn't matter whether it's like this group data or the single data descriptive analysis. Which one are we going to use, the mean? Because as you can see here, I'm sorry. So here we have this, the mean is 7.608, and we can, from the single data, the mean is 7.48. So it doesn't really make any significance. So we just can find like above the average, which is from 8 to 11. Above average sleep is more than 7 hours. So it means that from 8 to 11 hours. So as you can see, let's see the graph again. So from 8 to 11. So here we have 4. 4 plus 4, 8. 8 plus 2 is going to be 10. And 10 plus 2 is going to be 12. Now there are 12 people, 12 teenagers that fit into this, that they feel passionate to start their activities. And what I'm asking is, what about the one that don't feel passionate to start their activities? So I'm talking about the teenagers who sleep under the average hours, the average time to sleep, which is below 7. So it means from 7 to below. So I'm just going to subtract it, 23 minus 12 is 11 people. So I just input the 11 into the number of occurrence and the total. The total of the data. When we're going to get the 0.78. So it's like saying that, oh, what's the chance that teenagers in Indonesia is going to feel passionate to start their day when they woke up the next morning, after they sleep about below average time and use the smartphone up to 30 minutes hour, and we're just going to say, oh, it's likely to be like 47.8%. I think that is what it's like, because probability is like, as its name is like the probability. And that is my presentation about the statistics research. And this statistics research is for the mid exam, for the mid examination. So yeah, thank you for your attention till the end. I really appreciate your time. Thank you for giving your time to me. And I know that this presentation is not perfect. I still have many flaws, and of course I'm still learning, and I'm eager to learn more. And thank you for the attention. This is it from me. Have a nice day.